In the last class, we discussed about what are the types of errors, how the errors are introduced in the instruments. Now, what are the statical analysis of random errors? Let us discuss in this video. Statical analysis of random errors. Random errors are these are errors which are due to unknown causes. What are the causes for errors? We can't know. Few random errors are usually occur in well-designed experiment, but they become important in high accuracy work. How to reduce these random errors? What are the statistical analysis of random errors? Let us discuss now. To find the true value of measurement from n number of readings, the following methods are to be used. In any experiment, while conducting any experiment or calibration work, the readings should be taken, number of readings should be taken. Why? Because of to reduce the random errors. There are so many methods to reduce the random errors. One is arithmetic mean and median, standard deviation, variance. These are the various methods to analyze the random errors. What is arithmetic mean and median, standard deviation and variance? Arithmetic mean means it is defined as the set of values or readings of same measured quantity. Arithmetic mean is defined as the most probable possible value. The most probable possible value. How can we calculate the mean of so many values? The mean of so many values. Mathematically, arithmetic mean means number of readings divided by total number of readings, how many count we taken. Let x1, x2 and so on are the so many readings we consider. After that, the count n, number of count is n, then x mean equal to x1, x2 and x3 and so on, xn by n. That is summation of all readings divided by total. It is simple meaning that arithmetic mean means mean of, or it is average of so many values, x1 plus x2 and so on up to xn divided by n number of readings. That is the arithmetic mean. The statistical analysis of random errors is important points are how to calculate statistical analysis of random errors, arithmetic mean, median, standard deviation and variance. That is arithmetic mean means it's simply average of so many values. Now we go for median. What is median? Let us discuss now. What is median is defined as the closest approximation to the arithmetic mean value. It is defined as the closest approximation. What is the close value to arithmetic mean value? That is median. Generally, this value will be considered the middle point, middle of value may be referred to arithmetic mean. It is a very closest. For large number of readings, median is evaluated instead of arithmetic mean, which is a cumbersome task. It is where median is easy to evaluate true value. Median is defined as the value of the middle reading. The value of middle reading will be considered set of readings arranged in ascending order. If the set of readings are arranged in ascending order, then the value of middle one is a very near to close to average value, that is mean value. Hence arithmetic mean value it is near. For set of readings, if you ascend or if you arrange the values in ascending order, then the x median is given by xn plus 1 by 2 for even number of readings. For odd number of readings, it is xn by 2 plus x of n1 n by 2 plus 1 by 2. For example, if there are 25 readings arranged in ascending order, x median is calculated by x25 plus 1 by 2. That is an odd number. For odd number, for even number, 25 readings are, it is odd number. For odd number we have to plus 1 but divided by 2 we have to consider. That is for odd number. For even number, this we have to consider xn by 2 plus xn by 2 plus 1 by 2 for odd and median. This formula is for 20 readings. 20 is a even number. For that x20 plus 1 by 2, x21 by 2, that is that value gives 21 by 2 means 11th value will be considered as a median. By this method we can reduce random errors, or this is one of the method to analyze the static error. Another one is standard deviation. It is also important. What is meant by standard deviation? Standard deviation Coming to standard deviation is defined as the deviation of so many readings. Suppose the value is 2 amps or 3 amps, how much it is deviated, 0.1 or 0.2, 2.1 if the instrument gives, then that is a 0.2 is the deviation. The standard deviation is defined as the square root of sum of all deviations divided by total number of readings we taken. It is a simple definition that is denoted by sigma, that is sigma equal to deviation 1 square plus deviation 2 square plus deviation 3 square up to so on dn square by n, the square root gives. Hence we can in the form of summation sigma I equal to 1 to n square root of di square by n. That is the standard deviation. Simply remember this formula. What is standard deviation? That is standard deviation sigma equal to d1 square deviation 1 square square root will be considered. Square root of d1 square plus d2 square and so on up to dn square by n. That is standard deviation. If the readings or number of readings are less than 20, the standard deviation can be calculated as from this square root of d1 square plus d2 square and so on d20 square by n minus 1 readings will be considered. If the readings are more than that, n minus 1 will be neglected. Now what is the variance? Variance is defined as square of standard deviation. Square of standard deviation is nothing but variance. What is variance? It is also known as mean square deviation and is expressed as standard deviation square. That is sigma square. Sigma is nothing but standard deviation. Now another topic is signal. What is signal? What are the various characteristics? The chapter 1 name is characteristics of signals and their representation. What is signal? Signal is a function of time. Any signal is a function of time. Independent variables that carry some information. What is a signal? A signal can be represented with respect to time. What is the value? Then it is a signal. A signal is a function of independent variables that carries some information. Any signal carries some information. Modulation and demodulation and different modulation techniques. What are the delta code modulation, pulse code modulation? Different topics will come in modulation. A signal is a function of independent variables that carry some information. Already you studied in digital signal processing, ramp signal. The signal test signals are standard test signals are one is ramp signal and impulse signal. What is signal? Introduction to signal. Now it is one of the topic in unit 1, introduction to signals. Signals are variables that carry information. It described as function one or more independent variables. Basically it is a physical quantity. It varies with some independent or dependent variables. That is with respect to time also it can vary. Signals can be one dimensional or multi-dimensional. What is signal? Basically it is represented as a function of time. With respect to time, if the magnitude is 0 or if the magnitude is 1, then it is a unit ramp, unit step signal, like that. A signal is a function of variables that can convey information in the physical phenomena. Example, V of t, I of t, X of t, or the blood pressure, temperature, or these are the signals, one dimensional signal and multi-dimensional signals. Basically, what is a unit impulse signal? What is the impulse signal and ramp signal and step signal? Three signals are used to test any equipment in electrical power systems. Why? Because what is impulse signal? An impulse signal has zero value except at t equal to 0. Except at t equal. What is a unit impulse signal has zero value except at t equal to 0. Except at t equal to 0, the signal has it has infinitely high value of t equal to 0. That is del of t equal to 1 for t equal to 0. At 0 time it has one magnitude, where except at t equal to t is not equal to 0, the magnitude is 1. That is a discrete time signal is given by del of n equal to 1 and n equal to 0, whereas discrete time signal and continuous time signal 2 can be represented like this unit impulse signal. Impulse signal, we have to remember that del of t equal to 1 for time t equal to 0, that is represented in the diagram, whereas discrete time signal we can represent del of n equal to 1 or n equal to 0. Similarly, what is unit step signal? Step signal has unit step signal means magnitude is 1. Continuous time signal u of t, it can be represented. Unit step signal is represented by u of t. U of t equal to 1 for time is greater than or equal to 0. For less than or equal to 0, the signal amplitude is 0. A unit step signal has unity value for greater than or equal to 0, else 0 value it is. In discrete time signal, we can represent the unit step signal as in right side of the diagram. U of n equal to 1 for n is greater than or equal to 0. Un of 1 equal to 0 for n is less than equal to 0. That is unit step signal. Similarly, we go for what is the unit ramp signal. A ramp signal has unity slope value for t is greater than or equal to 0. The ramp signal, continuous time signal and discrete time signals, two signals. R of t equal to t for t is greater than or equal to 0. R of t is the ramp signal to indicate. R of t equal to 0 when t is less than 0. Similarly, R of n is the unit ramp signal. Simply represent these three signals. What are the characteristics of signals that already you studied in digital signal processing? That is unit ramp, unit step, unit impulse. Impulse has 0 at time 0, it has magnitude 1 unit 1. Similarly, rectangular pulse signal. What is rectangular pulse signal? Has unit amplitude within a time interval, otherwise it has 0 value. That is g of t equal to 1 for time period minus t by 2 and plus t by 2. Between that, the magnitude is 1, except that it is 0. That is rectangular pulse signal. These are the various test signals that can be used. After that, we go for modulation. What is modulation? Modulation is a process in which one of the characteristic of signals to be modified by using another signal known as modulation. It is any one of the characteristics, either frequency or amplitude, we have to modify by using another signal. That is known as modulation. Modulation is the process of converting one signal to another form in the phase or magnitude, like that. If you change the amplitude of one signal by using another signal, modulating signal, that signal which is, what is carrier signal, what is modulating signal, we have to know. First one is carrier signal, the signal which carries the information which is to be modified for transfer the longer distances, that is carrier signal. The signal which is to be modified is known as carrier signal. It carries the information. Whereas modulating signal or reference signal, it is. In pulse width modulation, we are using pulse width modulation signal, PWM technique. If you are using, it is a modulating signal. Modulating signal or reference signal. The signal which is used to modify characteristic of carrier signal is known as modulating signal. Modulating signal, it is. Carrier signal carries the information. Modulating signal has higher frequency that carries the information of carrier signal. By combining modulating and demodulating carrier signal, by combining these two signals, the data can be transferred. That is, the process is called as combining the two signals is known as modulation. The modulation is the process of combining by which one of the characteristic will be changed by combining carrier signal and modulating signal. Now we go for what is modulated signal. The signal which obtained after the modulation is known as modulated signal. After pulse width modulation, what is the signal we obtain in inverters? That is modulating signal. It is the output of modulation, modulated signal. What is the difference between carrier and modulating signal and reference signal, modulating signal also known as. After the final output is modulated wave or modulated signal. There are so many methods for modulation techniques. One is modulation is the techniques are classified into two types basically. One is continuous wave modulation and pulse modulation. Continuous wave modulations are divided into two. One, angle modulation and amplitude modulation. In angle modulation, frequency modulation and phase modulation, again two types. Angle modulation, this or frequency and phase both will become under angle modulation. Whereas amplitude modulation, that is continuous wave signal. And second one is pulse modulation, again classified into, that is second one, pulse modulation again classified into four types. pulse width modulation, pulse chord modulation, pulse position modulation, pulse amplitude modulation. These are the 4 methods used in pulse modulation technique. Okay, basically modulation techniques are 2 types. One is continuous wave modulation and pulse modulation. Continuous wave modulation are classified into angle modulation. Here either frequency or phase angle will be varied. Amplitude modulation, it consists of only amplitude will be varied. Coming to pulse modulation techniques, there are so many ways to control the pulse modulation technique. One is pulse width modulation technique, that is PWM technique we are using in inverters. Pulse chord modulation, pulse position modulation, pulse amplitude modulation. Again, these are classified into analog pulse modulation and digital pulse modulation. Pulse modulation techniques again. Analog pulse modulation techniques are pulse width modulation is analog, pulse position modulation is analog, pulse amplitude modulation also analog modulation. The 2 digital modulation techniques which are important is pulse chord modulation PCM, that is, and delta modulation DLTA, delta modulation DM, it is also digital modulation. What are the digital modulation techniques present is pulse chord modulation PCM, and another one is DM, delta modulation. PCM and DM are the 2 digital modulation techniques we are using. Coming to one by one, what is continuous wave modulation? In continuous wave modulation, sine wave was used as a carrier signal, and it has again divided into 2 types. One is amplitude modulation and angle modulation. In amplitude modulation, what we are varying, amplitude of the carrier signal is varied. If you assume the carrier signal EC as a one carrier signal, then amplitude of the signal is ES, then ES is equal to AS sin omega ST, where omega C and omega S are the angular frequencies of carrier signal and modulating signals. EC is the carrier signal, AC sin omega CT, whereas modulating signal is ES equal to AS sin omega ST, where WC and WS are angular frequencies of carrier signal and modulating signals. This is the block representation of what is the process of modulation, amplitude modulation process. The amplitude modulation process, it is an amplitude modulation process happening. Modulator, it is a modulator. The modulating signal, Fs of t, it is the modulating signal. The carrier signal we are applying for the modulation. What are the 2 inputs we have to give for modulator is modulating signal and carrier signal. Carries the information. Fc of t is carrier signal and Fs of t is modulating signal. 2 we are applying for modulator or amplitude modulation. The output we obtained is Fs of t, Fc of t. The output according to modulating signal, this signal is modified. You can see according to modulating signal, the modulating signal frequency is more as compared to this frequency, and the output of signal is this entire signal will be converted into modulating signal. If the modulating signal is like this, the carrier signal has so frequency like that, Fc of t, then according to the modulating signal, the carrier signal will be converted. That is the output of, it is a modulated signal. It is the modulating signal, it is the carrier signal, it is modulated signal. Amplitude modulation of sinusoidal signal, that is. The output ECM, that is output waveform, can be given as AS sin omega ST, that is carrier modulating signal. AC is the carrier signal equation. Then output of that is AC AS by 2 cos omega C minus omega ST plus cos omega C plus omega ST. That is the output equation simply for amplitude modulation. Similarly, carrier modulating signal, output signal, how can we vary this diagram? In this modulation, what will happen? You can see in this below diagram. This is the carrier signal. A is carrier signal and B is modulating signal. C is modulated signal, output of modulation. You can see this is the carrier signal having the frequency. One frequency will have, that is omega C is the carrier signal frequency. Now it is modified. The signal whose frequency to be modified, that is carrier signal or whose amplitude to be modified. Here the carrier signal amplitude all will modified more than rated frequency, that is this is the output frequency. Here we can observe what is how the signal carrier signal is modified in accordance to the modulating signal. Actual information is there in this information, but to transfer the information for longer distances we are using modulation techniques. In that modulation technique we are using pulse amplitude modulation, pulse code, different modulation techniques are there. It is the signal, actually this is modified like this. It is the modulated signal. The same representation we represented here also. Now we go for another type modulation. This is a theory about that. And another one is angle modulation. It can done, angle of carrier wave is varied according to the modulating signal. The carrier wave angle means phase or frequency, both will be considered. Angle means either phase or frequency. Phase modulation and frequency modulation, two types are there in angle modulation. In frequency modulation, the modulation process in which frequency of carrier wave is varied, the frequency is, whereas phase modulation, phase of carrier wave will be varied. That is simple. Angle modulation are two techniques, phase and frequency. Coming to pulse modulation technique, it is very important topic. Pulse modulation, analog pulse modulation and digital pulse modulation technique, already described previously. Analog pulse modulation is 3: pulse width modulation, pulse position modulation, pulse amplitude modulation. Coming to digital pulse modulation techniques, digital pulse modulation techniques are very important. PCM and DM, 3. PCM telemetry system, like the second unit also, it is very important. Pulse code modulation technique. What is pulse code modulation? Digital pulse modulation techniques. Nowadays we are using digital pulse modulation to transfer the signal for longer distances. We are using digital pulse modulation technique, PCM and DM. What are these three methods? We can understand pulse amplitude, pulse width, pulse position modulation. In pulse amplitude modulation, first one is pulse amplitude modulation. Amplitude of the pulse can be varied. It is the analog signal, that is pulse amplitude modulation according to the amplitude of the signal. The amplitude of carrier signal is varied. That is pulse amplitude. Amplitude will vary. Pulse width means width of the pulse can be varied. But here pulse amplitude modulation, width of the pulse is constant. In this pulse width modulation, you can go for next one is in analog pulse modulation, pulse width modulation. The pulse width of the pulse is varied, you can see in this type. In pulse position modulation, position of the pulse can be varied, you can see in another diagram. Pulse position modulation, it is the position of the pulse is varied. Coming to digital pulse modulation technique, which is very important, pulse code modulation and delta modulation are the two techniques we are using in digital modulation technique. To represent the data or any signal in digital form, we have to convert analog to digital signal. Actually, analog to digital converters are there. Before analog to digital, after analog to digital converters also we can use. It is a standard form of digital audio in computers. How the audio is stored in computers, you can see in mobile also the audio will be stored in digital form. Compact disc, digital telephone also we can use in pulse code modulation. In PCM system, the amplitude of analog signal is sampled regularly in uniform intervals. It is sample and quantization. Two methods are there in pulse code modulation. How to convert any signal to digital form, analog sampling and quantization. In delta modulation is the first order predictor. It is a 1-bit digital pulse modulation technique. 1 bit, 0 and 1s only it will be. Delta modulation quantizer uses two levels. One this level is 1 and 2. That is two levels are there, zeros and ones. Either 0 and 1 we have to use in delta modulation. Digital pulse modulation also similar to delta modulation, zeros and ones only. All the data will be converted to zeros and ones. How these are happening? Let us discuss in depth. This is pulse code modulation. What is pulse modulation? Pulse modulation is a type of modulation in which the signal is transmitted in the form of pulses. It can be used to transmit analog information. In pulse modulation, continuous signals are sampled at regular intervals. Pulse modulation can be classified into two major categories: analog and digital pulse modulation. Analog indication of sampled amplitude is infinitely variables, whereas digital indicates sample amplitude at the nearest predetermined. What are the types of modulation techniques? The basic block diagram of types of modulation techniques are: continuous wave modulation and pulse modulation, analog modulation, digital modulation. Analog modulation again classified into PAM, PAM, PWM and PPM. Pulse amplitude modulation, pulse width modulation, pulse position modulation. Digital modulation are classified into pulse code modulation and delta modulation. What is pulse modulation? Already you know that these are classified into pulse amplitude modulation, pulse width modulation, pulse position modulation and pulse code modulation. The analog techniques are three and digital techniques are two. One is pulse code modulation and delta modulation. We can represent all these three in one diagram. That is, it is the analog signal. After that it is pulse amplitude modulation. The first one is green color. That is, amplitude of the pulse depends on analog signal. And similarly, pulse width modulation, the width of the pulse is varied. If the amplitude is more, the width of the pulse increased. In pulse modulation, the position of the pulse is varied according to the analog signal. Pulse code modulation is digital technique that we'll discuss later. What is sampling? A signal is sampled at regular intervals such that each sample is proportional to the amplitude of signal, that is sampling instant. This technique is called sampling. Sampling and quantization, two methods we are using in digital code modulation techniques, that is pulse code modulation and delta modulation. Pulse code modulation, pulse modulation. Pulse code modulation comes under digital. Analog pulse modulation are three again. You can see pulse amplitude modulator, analog signal and pulse shaping network, FM modulator, HF carrier signal. The analog signal, amplitude of modulated pulses. These are the pulses. Simply one diagram. In one diagram we represented all this. Similarly, coming to pulse width modulation, PWM or pulse width position modulation or pulse length modulation or pulse duration modulation, it is also known as PWM, PLM or PDM, pulse width modulation. In this type, amplitude is maintained constant, but duration or length or width of each pulse is varied in according to the instantaneous value of analog signal, that is pulse width modulation. You can see the diagram in the analog signal. After that, width of the modulated pulses, it is a green color. The negative side of the signal is brought to the positive side by adding a fixed DC voltage. That is, we have to remember. Coming to pulse position modulation, PPM. In this type, the sampled waveform is fixed amplitude and width, whereas the position of each pulse is varied as per the instantaneous value of analog signal. In pulse position modulation, we are varying the fixed amplitude, but the position of the pulse is varied as per the instantaneous value of analog signal. In PPM signal is further modification of PWM signal. It is a PWM signal. After that, PPM signal we can obtain. We have to remember that PPM signal is obtained from PWM signal. It has positive thin pulses, 0 time or width corresponding to starting edge of PWM pulse and negative thin pulse corresponding to ending gate of the pulse. You can see in PWM signal, the thin signal is positive when signal is started, and negative, that is PPM signal, is negative downside, that is when the signal is ending, the width is ending at the end of the width, ending stage of the pulse. This wave can be further amended by eliminating the whole positive narrow pulses. The remaining pulse is called clipped PPM. This is the pulse position modulation. We have to remember in this is the pulse is positive when the PWM signal is starting. The positive thin pulse is 0 time or width it has. Corresponding to starting edge, it is positive. Corresponding to ending edge, it is negative. Again, coming to that, it is starting edge and ending edge. Starting edge, ending edge. Ending edge will comes in the negative ppm, whereas positive edge, positive ppm pulse position is with the very thin signal. It is that we have to remember. Coming to all these at one gallons, amplitude modulation, width, pulse width modulation, pulse position modulation, analog modulation techniques. Coming to pulse code modulation. Pulse code modulation is one of the digital technique. Analog signal is converted into digital signal by using a digital code. Analog to digital converter employs two techniques actually, ADC, sampling and quantization. The sampling is the process of generating pulses of zero width, and amplitude is equal to instantaneous amplitude of analog signal. The number of pulses per second is known as sampling rate. The sampling is the process of generating pulses of zero width and amplitude equal to instantaneous amplitude of the analog signal. The number of pulses per second is known as sampling rate of analog signal. Analog signal is converted into digital signal in two ways. One is sampling, another one is quantizing. Sampling is converting analog signal into instantaneous amplitude of analog signal into number of pulses per second. It is known as sampling. Quantization is the process of dividing maximum value of analog signal into fixed number of levels in order to convert the PAM into binary code. These levels are obtained called as quantization level. A digital signal is described by bitrate, whereas analog signal is described by frequency range. Bitrate is equal to sampling rate into number of bits per sample, that is pulse code modulation. Bitrate can be defined as sampling rate into number of bits per sample. It is the sampling, quantization and coding of digital PCM telemetry system. We are using levels 1, 2, 3 like that. The analog signal positive cycle is converting into pulse position modulation. After that we are giving for pulse 0, 0 and 1 like that binary codes we are given. The amplitude is 1, that is 111 for peak value, coming to that negative value. Whereas zeros and one, starting is 0 and ending is 1 like that PCM telemetry system. Quantization is employed for this PCM telemetry system. What are the merits and demerits? Analog digital communication system has more. The signals are very easy to receive because the digital communication receiver has just to detect whether the pulse is low or high. It detect, hence it gives the audio, and FM and AM signals have become corrupted over much short distances as compared to digital signals. Digital signals are clear voice, all this will be, hence we are obtaining good quality images, good quality audios nowadays as digital techniques employed for movies, OTT platforms. The signal loses power as the travel, which is called attenuation. When the signal is traveling, it loses the power, that is called attenuation. When AM and FM signals are amplified, the noise also get, but in digital modulation techniques we won't get. The noise may change the shape of pulses but not the pattern of the pulses. Whereas AM and FM frequency modulation and amplitude modulation signals can be received by any one of the suitable receiver, but digital signals can be coded so that only the person who is intended for can receive them. Based on this theory only the digital forms are working, because the movie or picture which is to be transferred, if you know the decoding, then only you can obtain. And another advantage of digital signal processing, that is merits of digital communication, is it can be stored easily, used to produce display on a computer or monitor, converted back into analog signal to drive loudspeaker also. That is the advantage of digital communication, digital pulse modulation techniques.